So we're going to do the reference book entry for reflections. And remember that a reflection is a rigid transformation, and that means that it preserves the distance and the angle measures of a shape. So the shape itself from the pre-image to the image does not change. So a reflection is a transformation that flips the mirror image, a set of points across a specific line of reflection. Such that that line of reflection is the perpendicular bisector of segments that connect corresponding points of the pre-image and the image. Okay, so that means a couple of things, and we'll talk about that in a second. So reflection is specifically described by the line of reflection itself. So when I say that I am reflecting, I always have to say what I am reflecting over, which line. Okay, so let me highlight this. So here's our line of reflection in this example. Okay, so segments connecting corresponding points of the pre-image to the image are perpendicular to the line of reflection. Which means they have perpendicular slopes, or slopes that are opposite reciprocals. Slopes that are opposite reciprocals. Okay, so for example, if we look at our line of reflection here and find some nice points, so like this one and this one, we see its slope is negative 2/3. So line of reflection, slope is down 2/3. So what I want to look at now is if I were to connect the pre-image and image points. So A to A prime with segments. Here's one. B to B prime with a segment. There's that one. And then our C to C prime with a segment. There's that one. I want to look at these slopes and see how these relate. So the slope of A to A prime, do you see that it goes up 3/2? So this is 3/2. And I don't necessarily need to count the whole way. I just need to find two nice points. So same thing here. I'm going to go right here from here to here. Do you see that here from B to B prime? We also have a slope of 3/2. So what do we expect from C to C prime to be? And again, doesn't matter where I draw this. So I could do it this way. This is down 3 and back 2, which would be -3/-2, or 3/2. Okay. we see that the slopes here are the slopes of the segments are perpendicular to the line of reflection. Okay, because they're opposite reciprocals. Okay, so that's one part of the definition, that we have to have that perpendicular to the line of reflection. The second is it needs to be bisected. Each of those segments has to be bisected by the line of reflection. And basically what that means, bisected means to cut into two equal pieces. So I need to check the distance. This distance has to be the same as this distance. This distance has to be the same as this distance. This distance, same as this distance. So basically, I can check distance in two ways. So from pre-image to line of reflection is equal to the distance from line of reflection to the image point. Okay, and we can check that using Pythagorean theorem. So using those right triangles and making sure that we have correct distances, or we could use circles. Okay, so for example, if I look at these distances here, you see that I have this right triangle here up 3/2. So there's my distance, right triangle with legs 3/2. I should have the same right triangle on this side. And if you look at that, there it is, a right triangle with legs 3/2. Okay, I could do the same thing. Let's look at C. So if I check the distance here and I draw this right triangle to the point where it crosses, this is a right triangle that has legs of 6 and 4. And so I want to make sure that from that point to my image point, that it's also a 6x4 triangle. Okay, so I'm guaranteeing that this distance is equal to this distance. So that's one way to check using Pythagorean theorem. The other way I could do it is by actually using my circles and verifying, because we know that a circle, the radius is the same anywhere. So what I'm going to do is I'm going to check the distance here from this point of intersection. So where it crosses that line of reflection to B, and there it is. And if I were to continue this circle, my B prime should lie directly on it if it is the same distance away from that center point or the point where it crosses. And so I can verify that way. And if you notice that it does actually lie on that line. Okay, so we're going to do another example here. We want to reflect this triangle across line M and list the new vertices. And this should say triangle, not D. I don't know what happened there. So this is triangle ABC across line M. So it doesn't matter where we start. We want to try and start with looking at our line of reflection because that's important, that perpendicular piece. So again, here's my line of reflection. I want to figure out what that slope is. So the line of reflection has a slope of, what is this? Over 1, up 1. So it's 1. So what does that mean the slope of my segments has to be? So segments connecting pre-image and image point. corresponding ones anyway, have to have a slope of something perpendicular to the line of reflection. So that would be the opposite reciprocal, which is going to be a -1 because we get 1 over 1 again. So what I'm going to do is I'm going to use that to help me. So I know for sure that for any of these points, I'm going to go down 1 and over 1. Okay, so here's a line. Basically, I think of it as like a ray shooting out. I don't know how far I want to go, but notice that that has a slope of 1. Okay, and so when I look at this, and I'm going to zoom in on this a little bit. Okay, it's got a slope of -1 as I'm going, but I need to check my distances. So do you see that this crosses kind of like a half? So to count down, I'd be going 1, 2, 3, 4, and it's not quite 4, it's like 3.5. I don't want to have to deal with that. So what I'm going to do on this one is I'm actually going to use my compass to verify how far along that line I need to be. Okay, so I'm going to put this on my compass. I know that this is where the point of intersection is. I'm going to measure that distance to B, which is there. And then I'm going to take this and draw my circle, which is really hard to do with the dot cam there. Sorry. There we go. Okay. So do you see that here is where that point has to be? So this is going to be my B prime. And so my B prime ends up at 0, -4. Okay. All right, now let me zoom out slightly so you can still see what we got there. All right, so let's try for, how about C? So again, I need that slope of -1, down 1 over 1. Now, do you see when I do that, down 1 over 1, down 1 over 1, I do that twice. So I'm getting this nice triangle right here. So I need to do the same thing here. So do you see I have that matching triangle? They both have rise and run of down 2 over 2, down 2 over 2. So this would be my C prime, and my C prime is at 2, 1. So I want to make sure to label this. Okay, and then I also need to do the same thing for A. So again, you could use either way, but do you see that this line segment here, AC, does have a slope of -1 already? So instead of going down 2 over 2, I'm going down 5 over 5. Now, I really don't necessarily have to do the distance to here because I know that this lies on that same line, and since this line, it's just going to flip the same way. I know that my A is going to go right here because it's on that -1 slope, which is what this slope has to be. So this is all in one line, which means that I can continue that to get here. Okay, so my A prime is at 5, -2. And then I want to make sure to actually draw my triangle and verify what I'm seeing here. Oops. So there, there, oops, and then from here to here. Okay. So this is my reflection. So again, I paid attention to the fact that the segments and the line of reflection have to be perpendicular to each other. And then the distances of those points were the same distance away from the line of reflection, wherever that is that they cross. Okay, so that's it.